nanoHUB.org.
Online simulation and more for nanotechnology.
Okay, so first we're going to have a little bit of fun with carbon nanostructures. And I was talking with Bob Ehrman the other day. He's making a flyer and wanted to make a volleyball net using carbon nanostructures. And so here you can see there's a graphene sheet in the center for the net, and the poles are made out of carbon nanotubes. It looks like it's an armchair carbon nanotube. And let's see, we need some players to have some fun here. There's a baseball player on the left and a golfer on the right. Choose your player and ready, set, go. Okay, player one, player two hits the ball back. Oh, get over in the net. Okay, so anyway, just a little bit of fun. All of these carbon nanostructures we can build using Crystal Viewer 2.3.4. And what I should mention is that there are several versions of Crystal Viewer. When you go to Crystal Viewer and use the link that I shared, you'll come directly here. And you want to make sure that you see this little note where it says archive version 2.3.4. If you end up with Crystal Viewer 3, you'll see different features. There's also a newer version, and that's something completely different. It's also a Crystal Viewer, but we're going to be playing with this version 2.3.4. So as long as you're logged into nanoHUB, you click the button to launch the tool. And this is one of the more traditional types of nanoHUB tool that's installed in nanoHUB. And one of the things you can do is resize the window. So I'm going to drag this up and over a little bit there. And so here's the view that you get. So one of the nice features that I was showing you is that you can take this lower corner and you can drag the window to be a different size. And also, if you double click on the title here, you can rename it. So if you have several versions running at the same time, you might want to know that this one is on Tuesday, or you can make whatever name that you like so that it's easier to see what's going on. So what we're going to do is we're going to keep the material system here, the material, instead of a crystal system. And for the lattice structure, we're going to change this from diamond to carbon meshes. And then let's start with the buckyball, carbon 60. And there's only one way to make a carbon 60 buckyball. And so there are no options here. We just click the button to simulate. And then the simulation is running. And then in a moment, we'll get the results back. So a bunch of information came in. Here is the buckyball, and it's not just an image. You can actually rotate it. You can zoom in, zoom out. There's a little panel on the side. So if you want to see the labels, you can see all 60 of these are labeled. There's carbon number 60 and 59. That's just the numbering that was in the input deck. It's not, these are all equivalent carbons, more or less. And what Bob wanted was to make an image with this. And so there's a little download button here. And if you click on that, you can select the image option, click the save button. And I do like the PNG format. And I'm going to change this to a standard format and change the background to transparent. Click the save button and wait a moment for a pop-up window to come in. And now I can save this as a file on my computer. And I'm going to just call this buckyball and save that file. And then I'm going to come back to the handout and just sort of scroll down here and see if I can insert the image so you can see what it looks like. So I'm going to upload it from my computer. There's the buckyball and there's the image, kind of large. So I'm going to just compress it down. You can also, use the draft version, but it's a pretty nice quality image. And again, if in the simulation tool you rotate it around, you can download different views of the buckyball. So a really nice, easy way to make some graphical elements. Now let's come back here and I'm going to show you how to make graphene, a sheet of graphene. Here, Lx and Ly represent the height and length of the graphene sheet. And I'll just guess some numbers. You know, you can play around with this on your own to make something of the size that you want. Let's say make this a 5 by 9. And we just want one sheet and everything else looks good. I'm going to click simulate. And again, just wait a moment while the simulation runs. And again, so the simulation runs on the nanoHUB servers. So you can run this off of an iPad. You don't need to have, you know, any local computing power. And there is the graphene sheet. And you can zoom in and out and so forth and, you know, put it at an angle, play with it however you like. And again, the same thing, you can use this download option. But I'm not going to save this one for now. I'm going to come back and show you the final carbon nanostructure, which is the carbon nanotube. And here, N and M are the chiral vectors. And if you hover over it, you can kind of see some information about what kind of input it's looking for. So I'm going to choose something, I'm going to choose a 5, and I'm going to make M equal to N. So it's going to be a 5,5 carbon nanotube, which that will turn out to be an armchair carbon nanotube. And then the third number here, the number of unit cells is, so if you look at the top ring of the carbon nanotube, there'll be 5 armchairs going around the ring. And then how long do I want the carbon nanotube? And let's make it pretty long, medium long. So I'll say 10. So we'll have 10 unit cells, and I'm going to click the simulate button. And then, yes, I see a question from, let me click simulate again. I think I didn't click it. Pam's asking if I can make more than one sheet and show the sheet stacking. Yes. Now I need to double check. Apparently there are a number of different ways that graphene sheets can stack, and we'll come back and take a look at that. Here's where stretching this out might help a little bit and making this a little bit smaller. It's okay if it's tiny in the window, because when you download it, if you use it, it will be bigger. So you can see the top edge there is the configuration that we know for armchair carbon nanotubes. You can also, you know, rotate it, look down the center. And if you were to make one of the chiral carbon nanotubes, you would actually see the chiral spiral here. So this is something really easy to use. I have a couple of resources listed in the handout. We use this a lot for Nano Days, where we have middle school's children building models and then also simulating these on nanoHUB. So yeah, if you come back here and to answer Pamela's question, if I come back to graphene, the number of sheets we can change to some other number. Now, like I said, there are different ways that graphene stacks, and I'm not sure which one they've selected here. And oftentimes graphite in nature, it's offset in a certain way, and I'm not sure that it shows up quite correctly in the simulation. So here you can see the stacking, and you probably have to play around with it a little bit and zoom in. And there's a little button here, this green cube, where you can change it from being a perspective to not perspective. And you can see here that these are actually not offset. And so that, depending on what you're trying to teach, that might be a little bit problematic. There are some other graphene simulators in nanoHUB, but I haven't checked them all to double check them all to see if they're stacked this way or if they're offset. So I usually just stick to a single graphene. That was just a really quick look at some of the things you can do with Crystal Viewer tool